Okay, so this is our midterm, and we are making a graphical user interface similar to the two previous labs which we have done before. And I am Steve Rodriguez, and with our team we have Fabian and Armando as well. So this is the introduction, and as I previously mentioned, this midterm is to show what we have learned up to this point throughout the course. We are working on this lab, which is similar to the previous labs which we have worked on. It is similar to lab 3 and lab 2. It is similar to lab 3 as we're making a GUI or graphical user interface app that is used to read and decipher the results that are received from the sensor. We are measuring temperature similar to lab 2 and lab 3, and similar to lab 2 we are using the buzzer and the LED sensor to signal when the temperature is above a certain parameter. The GUI tracks temperature in real time and shows the temperature in a gauge, which has colors which signal if the temperature is too hot or too cold or just room temperature. Due to what we have learned in the previous labs, we were able to make this lab work, and it was not as difficult as it was to understand the other labs. So this is a perfect example that we were able to do everything fine. Now on to materials. In the materials, we have the same materials as we've had for the previous two labs, as this lab isn't much different. We have the LM335 sensor, we have the 2.2 kilo ohm resistor, which we received from the lab materials that was provided to us with the lab. The 120 ohm resistor, the 680 ohm resistor, the 1 kilo ohm resistor, the Arduino Leonardo, jumper wires, the DC buzzer, lighter, LED, circuit board, and a laptop with MATLAB. I would also like to add that the resistors that we are using that were not supplied to us with the lab materials, these were received from other labs that we've done previously to this class, or just because we've had them laying around. Now on to Armando.
For the methods that we used for this lab, it was, as previously mentioned, very similar to lab number 3 in at least the physical circuit. But we created a different GUI. Our GUI right now, it's able to store data, not only just show the live data. It has gauges and lights that will basically alert us whether the temperature is above a certain threshold that we are actually able to manipulate. So we're able to indicate using sliders whatever threshold we want for our temperature. We also have settings that will clear our graphs and settings that will clear the stored data, as you will see in a minute. So this is basically the picture of how our GUI works. If you can see, we have a start and stop buttons. Those are just gonna literally start and stop the recording, or at least the live temperature recording. The little switch that says F and C is between Fahrenheit and Celsius temperature for our live and recorded data and our data collected. We have gauges that show the actual temperature at the moment in both Fahrenheit and Celsius. And we have two sliders. Those two sliders, one says threshold max and threshold min. The idea is that we're gonna set whatever temperature we want to, as our max temperature and our minimum. When it's below the minimum, the LED that we have on the bottom will show green. Then if it is within the two temperatures, it will show yellow. And if it is above that temperature, it will show red. We also have 3 boxes at the bottom left that says temperature in Fahrenheit, Celsius, and Kelvins. That shows live temperature data. And for our data collected, once we press stop, we're gonna see the data that we have collected. Every single data point is gonna be accentuated. And on top of that, we have the max value, the mean of that data collected, and the standard deviation. And when we click on the bottom that says clear BME, it's gonna clear the data that we have collected. So we're ready to collect another set of new data. So what I'm gonna show now is how the app actually works, how our GUI works. So I'm gonna set my maximum threshold to around 80, and I'm gonna set my minimum to around 60. What I'm expecting is that for this temperature alert to be on yellow, and for my status when I click start to be on green. As I do it, that's exactly what happens. My status is on green, it means that it's running. My temperature alert is on yellow because we're within the threshold. If I were to, let's say, increase the minimum threshold above the temperature that we have at the moment, it will show green. The reason I don't lower the actual temperature of the sensor is because we're having troubles actually lowering the temperature of the sensor without using something like ice, which can damage the board. And we are very careful about that. Also, the moment our temperature goes above the maximum, like right now, for example, let's see, we can hear the buzzer and the temperature alert goes red. So we click stop, the status comes and becomes red. We have our max value or mean and standard deviation. And this is the graph where every single point is accentuated. I'm gonna try that again, and I'm gonna try to fluctuate the temperature a little bit more. So we are gonna give it another shot. Wait, let me change my values. And I think that's pretty much okay. Clear, let me clear everything first. Make sure that everything is clear and let's go. So if I put my fingers on the sensor, I can expect the temperature to rise a little bit as my fingers are not too hot, apparently. It's quite hard to raise the temperature like that, I guess. Well, it is going up. It is going up. We're 78, 77, and there we go. So I click stop and I have a recorded data. That recorded data, I can move it, zoom it in, zoom it out. I can basically work with it and analyze the data as much as I want to. Once I'm done with that data, I can clear it, clear everything again. Let's change it to Celsius, make sure that it works. Now we are on Celsius degrees. I'm gonna put my fingers on the sensor once again, and we're jumping. So as you can see, our live recorded data works as soon as we click stop. By the way, the gauges are working, everything is working. We click stop and we have a recorded data all ready for us. And now Fabian is going to go for the next part of our lab.
Okay. This lab was very similar to the labs we've done before. It had some stuff from lab 2, some stuff from lab 3, and all that was put together. You know, some stuff were added, like the low gauge. I was telling you if the temperature was too hot or it was cold. We're in Miami, so cold doesn't really apply, but hot and cold was in there. And it was just putting everything we have learned so far in this course. Just everything came together, and it allowed us to show that we've actually learned this stuff and we just haven't been just winging it. So, in conclusion, the purpose of the actual midterm was just to be able to show everything that has been going through this course so far, and that we've actually learned the stuff, and we're able to put all that stuff together. As always, we had some stuff from other classes we've taken before, but you know, mostly the stuff from this class, and we're able to showcase and put everything together. Um, well, that's it.
One more thing that I would like to add before we end it is to make sure that we show that our app works for more than 1 minute for any amount of time. So we're gonna let the sensor run for about 1 minute so we can see that our app actually works for the intended amount of time. So we're just gonna let it run. I have my fingers on the sensor to see if I can basically make the temperature fluctuate a little more. We are on around 84, give or take. So yeah, let's just wait about a minute.
Also, while that runs, we, as requested, we put the whole code at the end of the lab report so it wouldn't take up the space. So you could check that out at the end of the lab report.
Here we see the buzzer goes off because the temperature went above the threshold that we set. In order for us to stop the buzzer, we would actually have to click stop because it's alerting us that our temperature is going too high. And it's also being alerted by the LED that says temperature alert. The temperature alert LED basically tells us, hey, you are above the threshold that you guys were supposed to be. So we're gonna click stop now. We can see that the app runs for an indefinite amount of time. So there we go. And here we have our data collected. Here we can see all the data with the correct axes and labels. So that's about it for a midterm.
Thank you.
All right, thank you.